In this video, I will go over the fundamentals or basics of NPN or BJT transistors. So, the transistor, NPN transistor, looks like this: base, collector, and emitter. So the device actually looks more like three junctions: an N junction, a P junction, and N junction. This is your base, this is your collector, and this is your emitter. So the way how we bias it, we put a voltage source in between base and emitter, that's your VBE, and another one in collector and emitter, so that's going to be your VCE. So what happens in the circuit, in the transistor, N area is electron-rich area and P area is hole-rich area, so more positive charges in the B and more negative charges in E. So what happens is that your electrons go from here with the biasing to the base, but because the collector voltage is higher than your base emitter voltage, this is your forward biasing, those electrons would continue going here. That creates a current this way. So your current, collector current, is given as saturation current times e to the power of VBE over VT. Your VT here is about 25 millivolts in room temperature, and your VBE is between 700 and 800 millivolts. So from this equation you can also write VBE is equal to VT times ln the natural logarithm IC divided by IS. So in a bipolar transistor there is a very limited base current. The base current is very small. It's because this area is small and we don't get much current from here. And the way how we express it, that the current from the collector is beta times the base current. So, and this beta, we call it current gain. It's as if you have a current from the base and that current is amplified from the collector. From looking at this IC and IE, we have the emitter current is IC plus IB. So you can write IC in terms of IB in terms of collector, IB divided by beta, and this gives us beta plus 1 over beta times IC for IE. And we can also write it that IC is equal to beta divided by beta plus 1 IE, the emitter current, and this term is also called alpha.